Hello. So I think we can start right away. So as Michal and Erin already pointed out, we also integrate with Spark, and this talk will be mainly about Sparkling Water, which is our integration of H2O and Apache Spark. So before we put our hands on the demos, I will introduce during the following 15 or 20 minutes, what is the product about, what are the news in the product, and then we can start playing on that with some simple natural language processing demo. So my name is Jakub or Kuba. I work at H2O. There should be way more people here, but for H2O, for Sparkling Water, it's mainly these guys. It's Michal Mohlava, our VP of Engineering at the moment. You saw him in the morning. He was presenting the roadmaps. Then it's Michal Kurka, head of H2O, and me, Kuba, working on Sparkling Water project. Because without H2O, there would be no Sparkling Water, but there are also lots, like everybody in H2O contributes to the project. So it's not just us, but everybody. So what is Sparkling Water? It's a transparent integration of H2O and Spark. So we try to take the best of Spark and the best of H2O into one simple platform. So you can choose to use data munging features from Spark, because Spark has a lot of methods available for data munging, data cleansing. But we also think that we have a powerful machine learning, so you can take the best of Spark and best of H2O. It's also great if you already have a Spark cluster deployed. That means that you don't have to change much in your code. You just need to replace, if you decide to use H2O, for example, you just replace your mlib calls or like scikit-learn calls for H2O algorithms. And it's kind of simple. So you have one Spark pipeline, just replace these calls, and you can switch to distributed manner. And what is also new thing in Sparkling Water and what is good for is that we are hearing a lot about driverless AI, and Sparkling Water is also integrating with driverless AI in a way that we can take the driverless AI mojos, the artifacts which driverless AI produces, and we can productionize them in Sparkling Water in a parallel way. We get this almost for free. It's just 4 lines of code, and it's a really nice solution that you don't have to spend years of coding to have something deployable. And what I already slightly mentioned is that we can take the best of Spark and H2O, is that all the functionality which is missing in H2O or is missing in Spark, we can take from the other product. So there are some benefits from using each of the platform. From Spark, we can use the natural language processing methods, which we are catching up at H2O, but Spark is still a little bit better at that place. Spark is also powerful with data munging and data cleansing. You can use SQL, Spark SQL over your data. And what is really nice is that you have the machine learning pipelines. That means that you can actually specify your transformations in form of one pipeline. You can then export the pipeline into one single artifact which you can deploy. And it's also language independent, so that you can take the pipeline in Scala or Python, and then you can deploy it in any language you want. It can be Python, Scala, or R. When it comes to H2O, we think, advanced algorithms, which are pretty speed and accurate. They are fully distributed. As Michal was doing introduction of H2O, they were written from scratch, so they should be really fast. And we have also graphical user interface, the flow, and you can use any client you are familiar with, R, Python, or Scala. I will just present 3 use cases, or maybe 4, how Sparkling Water is usually used. So this is the first one. What we can see is that we are using both platforms. We use Spark to load the data and do some data munging. Then we switch to H2O. We just need to convert the data frames from Spark data frame to H2O data frame and do the modeling. So we can train any model available inside of the H2O platform. And after that, we can do the streaming, do the predictions in Spark or H2O. It's up to us. The second use case is almost very similar to the first one, except that we can seamlessly switch between Spark and H2O when we do the data munging, data exploration. So we can use H2O and Spark, vice versa. We can convert the data frames back and forth as we wish. The more interesting use case is the stream processing. What does it mean is that usually you train your model and you want to deploy it in production on some streaming data. User clicks on some links, your customer produces some data in some streaming manner, it's being uploaded to S3 or some data lake, so you want to process it in real time. So that you use Spark Motor to create your offline model, you use Spark to load the data, you use H2O to create a model artifact, and you export it using the Mojo. It's our format how we store the models. It's a shortcut for model object optimized. And that's how we in H2O store the model informations. Once you export the Mojo, you can actually use the Mojo and take it into production in a stream pipeline. So again, you set up Spark to as a streaming application in the way that it will be reading data from, for example, S3 bucket. It will apply the transformation in the same way as you did in the offline pipeline, and then it will take the Mojo for scoring in production. And this sounds like a lot of code, but actually it's like 5 lines of code if you see it in a script. And the last use case, there's also lots of ways how you can use Spark Motor, but this is the newest one, is that instead of using H2O free to train your model, you can actually use driverless AI and think of Spark Motor as just enabler of the model, the tool which puts your model into production. So we use Spark for data munging, we use driverless AI for automatic feature selection and modeling, and then we take the Mojo. It's a different artifact than the original H2O free Mojo. We would like them to converge at some point, but right now they are different. And you can take this Mojo and deploy it in the same way as I mentioned before. I already mentioned the Mojo, and Mojo pipeline is the one which is used in driverless AI. The pipeline is there used for because we have several stages in the Mojo for the feature extractions and the training itself. What is nice about that is that you don't need H2O running to be able to play with that, to be able to productionalize this. So if you have any platform or any framework which you use for productionalization, you can just take the Mojo, fit it in, and you don't have to start H2O cluster. Just few feature we just added, and what is the roadmap before we can start. So we added a few new features into Spark Motor. The major ones I listed here. We have also lots of bug fixes. If you go to our GitHub, it's open source project, so you can see, you can contribute. We integrated with driverless AI Mojo so that you can load it in Spark Motor, productionalize it. We are working on the more tight integration with Spark pipelines. We are exposing more algorithms to Spark pipelines, such as today I merged the support for H2O GLM into Spark pipelines, so you can start using this algorithm from within Spark pipelines. We have also support for enterprise security, so we don't just play around with local stuff, but we also support enterprise customers, so we have support for Kerberos, LDAP, Kerberos clusters. So if you SSL communication between H2O nodes, so it can be really secured, it can be configured according to your needs. We are also integrating with enterprise team, which is currently managed by Ondra. And it enables you to manage H2O clusters and Spark Motor clusters in enterprise environments. So you can list H2O clusters, you can spin the clusters from that environment. It's a nice UI environment, and it actually shields your users from touching the YARN infrastructure themselves. So the administrator just configures it, and you can just spin some clusters in a nice way. So we have full support for Spark Motor inside of Steam. So you just go there, you click on deploy, and it will start Spark Motor. You have access to Shell or Python or Jupyter notebooks, and you can interact with those clusters. We have also support for Conda packages in PySparking, so you can install packages from Conda. And last thing, but it's also very important, are technical fixes, which means that we stabilize the client a lot, and there is a speed up by several percents if you use PySparkling or RSparkling. The fix done by Michal Kurka. The machine learning pipelines I will mainly introduce during the demo because we will be using them. But in short, what they stand for is that you create your transformers, for example, delete this column or add this, create this another feature based on the other ones. And you create one single artifact of it called pipeline. It can also contain model steps for model training. When you finish the model training, it actually turns itself to transformer. So we have just one simple pipeline. I will explain it more during the talk. And as I said, it integrates with the H2O and driverless AI modules. So what is the where is Spark Motor going? Michal already gave us a perfect roadmap in the morning, which was a little bit more abstract. So when we go to more details, what we already did is the Steam integration, support for Spark 2.4, and XGBoost. What we are currently working on is actually finished are the fixes for client, the full API parity in H2O algorithms in pipelines, so such as that we exposed H2O GLM in the pipelines. We are working on the Kubernetes support for Spark Motor and on the deployment templates. What that means is that, for example, from Steam, you would be able to start Spark Motor on AWS or Azure using the one-click deployment. Other thing we will be working on is integration with Spark 3, which brings the project Hydrogen, which would allow us to be more stable. As Michal Kurka already mentioned at the end, that we would like to use Spark Motor as a computation backend for driverless AI. What does it mean? That driverless AI could actually create a recipe how to train a model, how to do the feature extractions, and how to train a model. We would load the recipe inside of Spark, and we could actually train on big data. And then there are technical improvements, such as that we could run on subset of nodes in Spark environment. And there are like future tasks which we would like to work on, such as that you would start H2O on demand, and that we could scale automatically according to your needs in your cluster. So this is just that we have a ecosystem which is unique across different languages. We have Python, R, Scala, and you can see that the code is very similar across the different languages. R differs a little bit more, but you can see the connections. It's very, very similar. We try to be unified across the languages. Last two slides again about Spark Motor architecture, and then we start playing with it. Spark Motor supports two execution modes. The first one is called internal backend. The second one is called external backend. How they differ? This is really for another presentation. I will be super concise. In the internal backend, we have a Spark cluster, and inside of each executor, we start H2O node. So we can think of this as a cluster inside of cluster. This has several benefits, and for example, one of them is that we share the memory. H2O share the same memory with the Spark executor. That means that we can be more fast. We don't have to shuffle any extra data, and it's really easy to spin up. It has some technical difficulties when you really want to scale, which are fixed by the external backend, which is actually separation of these two clusters. You start your H2O cluster separately from the Spark cluster. It has two benefits. You can configure those two clusters in a separate way. You have more control over your resources, and this is also more stable when it comes to some specific use cases and environments. We will be playing today with internal backend, but what is nice is that if you use internal or external backend, it doesn't change anything about your use case. It's just a matter of like starting H2O context with different set of parameters. Once you start H2O context, there is no need for you to worry if it's internal or external backend. But that was lots of slides, but we should be playing with the code. So let me open the Jupyter notebook. Let me make it bigger. So I think you already know the instructions how to open Aquarium. So you just go to aquarium.h2o.ai. You register there, you log in. There is a sparkling water. You go to the Jupyter notebook. and then you need to click through the directories. There is I can actually show it to you. So this is the lab I'm actually using. You go to this, you open this Jupyter. This is the lab I'm using. There is this Jupyter URL link. You click on, and you should see something like this. You select sparkling water hands-on and sentiment analysis and the Amazon Fine Field pipeline. So if we are there, perfect. Where is the notebook I used? It's here. So what is this demo about? I already introduced sparkling water. In this demo, we will try to predict it's a sentiment analysis on Amazon Fine Field reviews data. So we have reviews of customers of restaurants which were provided to Amazon, and we wanna predict whether the feedback was positive or negative. Just this simple model, and we want to use sparkling water and Spark pipelines for that. And once we are done with this, we will put this model into production. So this is, maybe I can make this bigger. So this is another picture which I was showing slightly different way how to show the same thing I was talking at the start. We will do the offline training in Spark, and at the end we will use this model artifact for the online stream processing. So the first thing we need to start with is to start Spark. So if you just execute this cell, you should have a Spark ready. It's running in a local mode. The asterisk there means that it's using all the cores it can use. You can also, if you want to play with it locally, you can use just local. We can also start on Yarn, Yarn client mode, Yarn cluster mode. Spark 2.4 can also run on Kubernetes. So it's basically up to your needs, what execution backend you need to use. You can go to Spark UI. This will probably just not work because it's behind the it's a Docker address of this machine, but usually you can go there. The other thing we need to do to be able to start with sparkling water is to start H2O context. In Spark, we have something like Spark context, which is the basic entry point to your Spark applications. You start your Spark context, which actually takes care of starting all the executors, and it's used for submitting the Spark jobs. In case of sparkling water, we have something similar, which is called H2O context, and it serves the same purpose. It's used to start H2O nodes across your cluster, and it's used to submit H2O jobs to your cluster and converts between two different data frames, Spark data frame and H2O data frame. So what I'm going to do here, I'm going to spin up myself a H2O node inside of this Spark cluster. This will take a while, but it won't be long because I'm starting it locally. So here we are. So we can see that I just started myself a cluster. You can see how much memory we are using, the IP address of the flow, some API extensions which we use. We have XGBoost available, AutoML, and the overview of the nodes we are running on. This is just local node, so we have just one driver. If it would be distributed, you would see more nodes here. So right now we have a cluster prepared, and we can start playing with the data. So the first thing we need to do is load the data. You can actually choose which you want to load the data using Spark or H2O. In this case, it's a CSV file, and we are loading the Amazon reviews training data set. You could also use the Spark CSV method, which actually loads the data as well. What is nice about this method, H2O upload file or H2O import file, is that it will nicely infer the types of your data. So we have really a lot of heuristics how to infer the type correctly, so you don't have to specify the schema manually. So that's why I chose H2O to load the data instead of Spark here. So we just loaded a data set. And we can explore the data in Flow. So I can try open Flow from here. This is the private IP address. I need to use this thing. Perfect. So if you want to go to Flow as well, you need to replace, if you click on the link, you need to replace this IP address by the address of the Amazon machine where your Jupyter notebook is running, if you want to play with Flow as well. And I can actually see the data set I just loaded here. I can list all the frames. I have the reviews.hex here. I can click on it and I can see the columns here. So what columns does this data set has? It's a ID, product ID, user ID. These columns are not that relevant to us for the modeling purposes. Profile name, helpfulness denominator, some other informations. What is mostly important for us in this case is the score, which is score from 1 to 5, how good the review was. The time when the review was submitted, was it Monday, Friday, weekend, night, evening or morning, and the summary, the message of the review. Oh, actually no. Summary is another categorical expressing how good the review was. It's in the text. We store the message of the review. So you can also see the other information in this flow, such as the chunk distributions, how we distribute across the cluster data, and so on. But right now we have the data set loaded, and because we want to use Spark pipelines, we need to convert data to Spark frame. Spark knows how to work with Spark frames, not with H2O frames. So we just need to convert the data frame. So this call H2O context.s Spark frame will convert this H2O frame to Spark frame. So it's done. Right now we just loaded Spark frame. We just created a Spark frame, and we can create a schema of it. So we can just see the same schema we saw in Flow. What we also did is a small trick here, and we just saved the schema into file. You can see it there. We saved the schema as a schema.json, and what the trick does is actually when you deploy your application into production, you don't have to manually. You sometimes don't know. It would be hard to infer the type of the data automatically because you have just one row at a time. So by this, we can actually save the schema at the training time and use the same schema during productionization time. So you have the right schema at the time when you deploy the application. So we don't need the file right now, but we will use it later. Perfect, and now we start defining the pipeline stages. Ultimately, as part of this pipeline, we will train the H2O XGBoost model, which will help us to determine whether the feedback was positive or negative. And we start with a simple stage, which is called simple transformer, which is called SQL transformer, and that transformer is used to select specific columns and do basically run any SQL command on your input data set. So it's kind of flexible transformer. You can do a lot with the transformer. It's provided by Spark environment. And what we want to do for our sentiment analysis, we are just interested in the score, time, and summary columns. We don't care about the IDs and user ID, product ID. They are not relevant to us. So what this transformer actually does, it just selects the score, time, and it converts the time from the Unix time into human readable time. That's this Spark SQL method from Unix time. And summary. And we select it from this. What does it mean? That it will select it from the data set on the input. In the pipeline. What we usually do is that we define the stages, and then we put them all in one single pipeline. We don't run them separately. But for the purpose of this demo, I will be always running the one stage right away, so we can see the immediate results to see how it behaves. And at the end, I will put all the stages together and run and create one single pipeline. So here I'm running the first, I didn't run this. So that's why it fell. I'll just create this stage, and I can call transform here. So I just, on the stage I just created, on the Spark transformer, I call the transform method on the input dataset, the review Spark, and I can show the columns, so I can see I just have score, time, and summary to get ourselves more familiar with the data we are working on. The score is 1 to 5, time is a human readable time, and summary is the summary. Another thing is what is good for the machine learning algorithm is to we can split the time column and create more columns. We have like human readable date time, but it's not ideal for the algorithm. What we can do is actually we can create day of the month, year, determine whether it's spring or winter, and it can help a lot the algorithm itself. So it's like very simple feature transformation we do in Spark. So you can see that I'm creating the day of month, week of the year, hour, and also whether it's the season. I'm selecting the season. Why is this important? When we are doing the sentiment analysis, it also depends, for example, whether it's Friday. On Friday, people might tend to give better feedbacks because it's after work and they are more happy. In winter, they might be more depressed, so they just... There is lots of ways what can improve, what can influence the behavior of this model. So that's why we create multiple additional columns like this and let algorithm, so algorithm can use these values. So again, I just defined another SQL stage. It hasn't run any code so far, and it's just stage definition, and I'm gonna run the stage now. So not much happened here. There is just few additional columns with a year, week number. Basically, I just processed the time and created additional columns. The next thing in this pipeline is that we actually are not interested in the neutral feedbacks. In this simple demo, we just worry about whether it's positive or negative. So neutral feedbacks, the feedbacks with the score 3, doesn't give us any interesting value. So we just trim those off. We again use the SQL transformers for these. So you can see that in the Spark SQL, if score is lower than 3, I'm giving it a negative categorical, otherwise positive. And I'm marking it as a sentiment column. So I can, again, load it. And you can see that we have a new column here, which says either positive or negative. Okay, perfect. So this is the basic data cleansing. If we go forward, so we can see that we have the words here as a sentences, which is again not ideal. So we will tokenize the messages. We will again use Spark transformer, which is called regex tokenizer. And what is it good for? Is it will take the data on the input, and it will tokenize it. It will actually create an array of words. It's simple, but it's good to tokenize the words if you need to work with the data more. So I'm specifying the input column, which is the summary. I want to split the words in the summary column. I'm specifying the output column. The pattern, I'm just going to split by the space. It's a regular expression, and I'm going to split by comma and space. And before I do the conversion, I want to convert everything to lowercase. So I again create this stage, and I can run it. And you can see that I just selected here, for example. You can see that the data has been split it into array based on words. Yet, right now, we still have words like prepositions, articles in the column we want to work on, which again doesn't bring us any value for the final model. So we want to trim those words as well. And for that, we will remove the unnecessary words, and we will use the stop words remover Spark transformer. Again, using the same API, we select the input column, we can refer the output column of the previous stage. In this case, regex_tokenizer.getOutput column returns the previous output column. We specify the new output column, and we again don't want to care about case sensitivity. Of course, in some weather model, it might be very useful to check the case sensitivity, because if someone writes something like it was horrible in capitals, that probably means something. But in this case, we are not training for this specific case. So I can again fit it. Also, what I did here, because it was hard to read when all these columns, what I just did here, I just used select method on Spark frame, which actually selects specific columns I need to see, and I can export them right away in the UI. So I have a sentiment summary and the clean summary without all the prepositions, articles, and bad words, which doesn't bring me any value. Okay, so right now we have all the words ready, and we want to hash the words, because we want to create a TF-IDF model on top of this. So first thing we need to do is create the count the occurrences of the words inside the data, inside the corpus. So before that, we can use either hashing TF or count vectorizer in Spark. Again, stage is provided by Spark environment. We decided to use count vectorizer. They actually serve the very same purpose. You can use hashing TF, which actually hashes the words to some space you specified. You define your hashing space, and you hash there the words. So there can be some collisions. But the hashing space can be any value you just define. The count vectorizer requires internal array of being the same size of the vocabulary you are using. But the additional benefit of this is that you can go back from the index to the word, right? So you calculated the number of occurrences for specific word in the data set, and you created a vocabulary. For example, vocabulary index 1 contains word hello, and you can actually search by the index the word back. In the hashing TF, it's not possible because the hashing function it's not reversible. So that's why we used the count vectorizer.
Continue to get some questions going. There's a ton of good feedback back and forth going. Maybe one of the screen, if you can put the slider for the speaker, would be useful.
Okay, we can switch to questions.
Here you see. Yep. Can you run sparkling on Kubernetes? There was another very interesting question earlier, which flew in how the memory models work between the two. So it'd be good to answer some of that.
So Spark 2.4 can run on Kubernetes. Spark Composer it hasn't been nested, it's planned for Q1, so it's still something we need to work on. But Spark itself can run on Kubernetes. And Spark Composer is just library to Spark. So that means it should just work out of box, but we haven't tested it yet. So if you want to play with that, you can definitely go for that. What does it mean? Mojo, it stands for Model Object Optimized, and it's you don't see the questions. Okay, so I just say it quick.
Yeah, we can see the question.
You can see the question there, but it's not the big screen. Okay. So what does it mean? Mojo, it's a Model Object Optimized, and it's our way how we store the model. So it's a H2O way how to exchange the model artifacts, both in driverless and in H2O free Spark Composer. Is H2O manipulating Spark RDDs when running ML algos? So when we are running algorithms inside of H2O, we actually don't manipulate the RDDs. RDDs are, you can't change the RDD. It's immutable. You always need to create a new RDD. But when we are working in H2O, we always convert the RDD or H2O or Spark data frame to H2O data frame on which we work on. Can I introspect Mojo models? The quick answer is yes. We don't provide any specific tool where you can go through the Mojo, but you can. It's just zip file. You can extract the zip file and go through the stages. Is the memory requirement of sparkling water cluster, does the memory requirement of sparkling water cluster depend on the data set size? Yes, of course, and rule of thumb is to select to give the cluster four times more memory than is the size of your data set. That also applies to H2O cluster.
Do you want to talk about the K cluster?
Yeah, I can.
You probably have this.
I think I introduced that in the beginning during the architecture slide. But when it comes to like tuning the memory, it's a little bit different in the K class S3 set or external cluster. That means that we separate H2O nodes and Spark nodes, and you can configure them separately. So that's also perfect because you can your data managing task might require more memory or less memory, so you configure a cluster for that, and then you switch to H2O side, and you can also configure the memory on the H2O side differently according to your needs.
I think the last one is a good one too. Do you have a reference architecture to deploy sparkling water in enterprise environments? Sparkling water has actually been one of our amazingly well adopted community project. We have booking.com famously talking about it in several conferences. We heard several mobile payment systems. Sparkling water is the back end for billions of transactions in mobile payment systems in India and Africa. We're seeing it, booking.com obviously is a massive cluster. Sparkling water is one of our, about a third of our customer base is actually sparkling water. So we get a lot of back and forth on that front.
Yeah. So I will continue with the answers. So will Spark support be in driverless AI? So I already quickly mentioned that at the beginning on the roadmap slide, and that is that driverless AI, we would like to use driverless AI as a generator of the receipt, how to train and how to create your features, how to train your data, and take this receipt and use it on the big data, really big data in Spark cluster. So that's how we plan to integrate more tightly with driverless AI and Sparkling Water. Do you support ML flow? There is integration of H2O or Sparkling Water with ML flow written by our well-known colleague in Databricks, but we didn't wrote it. Does Sparkling Water provide seamless switch between internal and external mode? So when you start Sparkling Water, you need to decide whether you will use internal or external mode. This is not something you can like switch dynamically between at the moment. So when you start your job, you start either in internal or external backend. What is the memory overhead between Sparkling JVM and Spark Executor JVM? I don't probably understand that question. There is
one question.
The memory for the executor, and in H2O we suggest the memory for executor and driver to be the same, so you run in the homogeneous environment. Spark RDDs distribute across multiple nodes. Does the same happen with H2O's data frames? Yes, H2O data frame is fully distributed platform, fully in memory, so it runs in memory. Does the SQL transformer use any specific driver? Can you write subqueries, row over partitions, unions, etc.? So this SQL transformer is actually, it's Spark SQL. You can also interact with like Hive using Hive JDBC. In Spark, the Hive support is naive, so you don't have to provide any specific jars. So you can select the backend when you start Spark. The Spark I just started, use it local Spark SQL database. You can connect to Hive, for example. Is there a preferred method to keep up with? Can you develop on the current application of Sparkling Water in India, Africa? Can you develop on the current applications? So if this question means if you can create specific applications. You can use Sparkle Motor anywhere. You can build applications on top of it anywhere. It's open source. We don't limit anybody. So that's my answer to that. Is there a preferred method to keep up with version changes between H2O Sparkle Motor Spark using virtual environments currently? So it depends on up to your administrators. Ideally, if you use Sparkle Motor, you don't have to install any additional dependencies. It's actually everything you download is what you need. You just need Java. If you use Python, you need to have some Python packages in your environment, and you can, of course, create virtual environments for that. But again, it needs to be unified across all the Hadoop cluster. Can Sparkling Water work with streaming datasets? Yes. If you follow, we will share the links to this presentation. If you follow that at the end, you can actually see how we actually productionize H2O mojos in streaming applications. Do you have a reference architecture to deploy Sparkle Motor in enterprise environments? Yes, as Sri already mentioned, we have a Booking.com. There is actually a use case available online, which you can watch. It's an amazing use case where we work together with Booking.com for almost 1 year to make them successful with Sparkle Motor. Thank you. Great.
I think it's not just a great Q&A. The team Sparkling Water in H2O is one of the smallest team with the biggest bang. Michal Maluhlava started the core. He was the chief architect initially and recruited Kuba. Kuba has been phenomenal in building an amazing presence worldwide. We just recently are beginning to add folks, so folks with Spark, Scala knowledge. We're recruiting heavily for Sparkling Water, so we'd love to kind of hear from you guys. But also deploy it. It's Apache V2 and pure play. Before we lose the audience, we have added some interesting talks, a couple of really phenomenal innovations that are lesser known, H2O talks that I want to bring on stage as well. I think I want to have Kuba present his, do you have a couple of more slides? Or
Today? Yeah, sure.
And then close.
So thank you, Sri. So I'll quickly continue with that until, okay, we have a kernel already. I just finished with this thing. So I'll take it more quick to get to the interesting bit at the end. So we're gonna hash the words here. We're gonna use count vectorizer for that. I already explained why we're gonna do that. Once we vectorize the data, we will create the TF-IDF model based on top of that. So that's used for we need to determine how important is the given word in the given corpus. So let me just create the inverse document frequencies model. And finally, after this stage, we will see how we can actually productionize this model into production. So this will take a while because you need to create a TF-IDF model. Here, the final stage is that we just want to remove extra columns we are not interested in. So I just selected myself the columns the model actually needs to have. And here I'm creating a H2O stage. You can see that the API is really the same as other Spark transformers. It has this really the same look. And I'm gonna train ourselves H2 XGBoost model. I'm not training here, I just defined the stage. And here I'm defining the whole pipeline. So I just defined the whole pipeline and I can call pipeline fit. And what it actually does is it will go through all the stages, apply all those transformers, run our XGBoost model, and give you final Spark pipeline, which actually inside contains H2O mojo. This will take like 1 or 2 minutes, so I will just go forward and explain the other stages. You can also try predictions. For that, you just need to load the data set, again, convert it to Spark data frame, as here. And what you just need to do on the model pipeline called transform. And it will just do your predictions. Again, it will go through all the stages. It will apply the result of the H2O. It will run predictions using the H2 XGBoost model and give you the results. So this will run for another like 30 seconds. And at the end, before we try to put it in production, we just save the model on disk so we can load it again, for example, in different application and productionize this. So how this, just bear with me, this will finish soon. So how we're gonna productionize this application is that we created a schema.json file which contains the schema. We created ourselves, or we will create soon the pipeline, which we're gonna use, and we will start like artificial data stream, which will be creating files on my disk, and we will be reading that periodically and running predictions on top of that. Okay, it's still training. Okay, it's fine. It's fine. Perfect. So we have the model. I can just show you how we can actually do the predictions here. So that was pretty quick, and you have the probabilities here. It's kind of trimmed output, but you have the probabilities here, and just using these 3 lines, you can do the predictions. But the most interesting bit here is the productionization itself. So from now on, you can imagine that we start totally new application. It doesn't have to be application which has H2O running in. It can be just Spark application. You don't have to start H2O cluster. So I just simulate that it's new application. I would myself start a Spark cluster. I would load the model using our API, the PySpark, this API. So I loaded a Spark pipeline, which actually contains H2 XGBoost Mojo inside of it. Here I'm gonna load the JSON file of the schema, and here I'm gonna simply start the artificial streaming process, which will be creating files on the disk. This simulates the incoming reviews from the restaurant visitors. Here I'm creating a Spark streaming data input. So you can see that I'm just specifying the output directory here as the input, and it will start reading the content of this directory, and it will apply the transformations on top of these files. Here I'm using the pipeline model which I just loaded on the input data stream, and the last thing I need to do is specify output data stream. Right now everything is set up, and because we want to see the results, I can run this code, and I can see that as data comes, I have the new predictions here with new probabilities. So you can actually see that I didn't lie at the beginning, that it's just 3 or 4 lines to productionize something, to productionize the code with H2O and sparkling water. I just loaded the data, I created the input data stream, loaded the pipeline, and created the output data stream. So it's really 4 lines of code which I need to do the basic productionization in sparkling water and H2O. What is also nice that instead of using H2O free Mojo, you can actually plug in inside driverless AI Mojo. In the same way, so you can actually prep your data in Spark and then use the power of driverless AI Mojo, which actually does the feature transformations and model training as well. So it's really a platform which brings all the Mojos we provide for driverless AI and both H2O free together, and you can productionize both. Okay, so that's probably everything from me. I think we already wrap up all the QA. So thank you again, and enjoy the rest of the conference.
Thank you, Kuba. As I mentioned, it's a high output teams, and Kuba is one of the core team behind sparkling water. Let me welcome 2 phenomenal data scientists. Start with the data science first. We did that with one of the projects with PwC, which led us to do general ledger.ai. It won the International Audit Innovation of the Year award. in 2017 and is on path for 2018 win as well. This team is, again, high product output. Mark Landry has been with us for a long time. 2014, he was on a panel at H2O World, the first H2O World. And that kind of gave us the inspiration to start building the Grandmaster teams. He's been core to building that data science expertise. He called me on his first day saying, what do I do at work? Well, you play Kaggle, and you do competitive data science, improve the core culture of the company to be more data science ready. Next thing you know, he brought Brandon on board. Brandon has been core to some of the work you'll see here. And together, they've been working on a very interesting project. How do you go beyond just simple algorithms and automatic machine learning algorithms to applying it to the real world? They work very closely with our prize partners. PwC is speaking at both the last two conferences at New York and London, and on how to really take this to the next level. AI applications, AI-first applications, are going to dominate the future. That's where software, hardware is evolving. All of AI-first experiences are going to be really thrilling, and I think this is the beginning of one example of that. So without further ado, I'll leave you to Mark and Brandon.
Thanks, Sri. So, yeah, this is going to be a talk. This is similar to a project we were doing at H2O London. So anyone who caught that, or online or here, we're going to mainly go through a little bit of that, and then actually this time we have some updates. So this came together a little late, so bear with us, but we do have results that are actually pretty exciting for us internally, and I managed to get a little bit out in here. So I'll go by this. It was about a 20-minute presentation now, so I'm going to try to go fast. Sorry about that. So our team, me and Brandon, we also have Shaket and Shenshens here as well. But there's a bigger team as well at PwC, like Sri said. There's a lot of interesting UI work that we do with them all the time, so we have some top-notch front-end engineers as well. But we're going to talk about a little bit about the back end that we're doing here. But a lot of what makes some of these products we've shown you in the past come together is the really fancy front end, the front end that really knocks you out. So like what Sri said, this is becoming more and more common as we've started it. So we started this project in about August with some designs a little earlier than that. And just watching the Super Bowl yesterday, saw something about Expensify. There's a lot of these kind of things out there that are reading OCR and understanding business context and trying to do it for you. Use AI to do that, whatever they're going to do. So that's what we're doing as well. So quickly, so business documents have is generically. We're going to walk you through. This is mostly focused on invoices, something we kind of all see. Invoices, orders, they look kind of similar. They're a little different for us, but very similar concept. Also, the specific document you may not be familiar with, but as a bank confirmation, is kind of we're looking at as well. A couple different angles of approaching this. So we're looking at a wider thing than one single-purposed invoice receipt, as you see a lot of people doing. So we're trying to go from the invoice you see on the left and just pull out the structured information so you can put it in a database. This is nothing too, there's all sorts of template tools that have been around there for a long time. I've used one probably 10 years ago. But this is going to be something that really uses the power of AI, the power of deep learning, to hit a lot of what I think we've seen as edge cases, where you can get something pretty simple pretty quickly, but you get lost in business rules if you try to attack it that way. Again, that's the problem challenge. We're using deep learning to do this. So far, mostly we will use NLP at some point. We've used a little bit of that at a driverless. We're mostly going to show deep learning and the image recognition standpoint. Sorry, go back one sec. Yeah, so the updates since H2O World. So some of these slides are based on where we were at the time, and we have definitely taken some progress there. So we'll show you a little bit of that, about that. And then if we can, how this all comes together, so something you can actually use inside driverless. A few ways we can put that back in the tool, and we should be able to discuss that as well. The first thing that we're hit with is usually, well, like I said, this has been around for 10 years, well, more. I just throw that number out there. But is this a solved problem? Oh, don't just use OCR. use Tesseract. There's some of the papers that are coming out, that's where everyone seems to start, and it wasn't entirely where we started, but it's a big basis of what we're doing too. So you can't get around OCR. It's a really helpful tool. We've demoed this, like Sri said, H2O World 2014, we're all doing MNIST. You can do you can classify digits, we can do this, but what we're doing here is a little different. So for one, we're not just reading every character. We are using off-the-shelf tools to do that part of it. But there's a lot of judgment that goes in this. When OCR messes up, what do you do about that? And for us particularly, there could be several dates. So OCR is going to give you the text, but not necessarily the meaning. So we're going after kind of the semantics of what this is, and that's important to our problem. We need to get the right date, not just a date, not just the max date, not just something that says this. An invoice date sometimes just hits you over the head with invoice date, and other times it's something very different. But in each case, we have to figure this out. And so it's a combination of tools, and actually our current workflow has really started to put some of this in place. So we started looking at other tools. Now we're really doing them. We've broken up the problem in several different ways. But the judgment piece is kind of integral to us. So on the bottom, you see kind of an OCR misread. There's some ways around this. So on the bottom, you see a balance. For us, the currency is very important. So you have euros and US dollars. It reads the USD just fine, but for whatever reason, the OCR read is going to it's using NLP, in the back. So the OCR that you can pull off the shelf, Tesseract is kind of the latest and greatest, and we're using that as well. But it uses deep learning underneath it, and it's going to use some of the NLP. But unfortunately, here it's gone and spell corrected essentially, or close to it. So it doesn't recognize EUR. It doesn't quite understand that there's a currency right below it, and we commonly speak in currency. So it has gone ahead and overcorrected it, if anything, that value, and that's a bad one for us. That's very important that we read that correctly. So we have to kind of find this mix between how can we make the OCR off the shelf. You can retrain Tesseract. There's a lot of things you can do with that. But there's a lot of problems that we've run into, and so a lot of what we're going to wind up doing is correcting some of the OCR. So it's come in, I think we called it OCR.ai now. This is just really a flowing project, but document AI, but OCR and the correction thereof has become pretty important in the last month or two, I would say. We'll show you a little bit more of that, but that's the general concept there, is that we can't have the OCR, we can't fail because OCR has stopped us at step one. And so it's kind of like we're looking at it as an ensemble approach almost there, and that's what our workflow will take a look at. This is kind of where Brandon comes in. So, we are using deep learning object detection. So this is not just dog, cat, mouse. Object detection is it's dog, cat, mouse, but then there's 400 of them on the screen, and so this is what you see in the computer vision algorithms. The driverless cars. That they're finding multiple things. Where are all the people? Where's the road? All sorts of different things, and where's the background? Importantly, is one of those. And so we are using those to do various mixes. When we put this out there in late October, early November, we were using it to do kind of everything. And what you'll see is we've kind of advanced our methodology to sort of get it doing the task, some simpler tasks. Then we were trying to get it to do everything under the sun at one point, so that it's not doing all the OCR at the same time. So it's looking for structures, and then we'll use and rely on the OCR to do a lot of this. So our workflow has kind of changed over time. And it's to really embrace the methods that we have rather than go after it and not reinvent the wheel. So we're using the OCR in a bit more tactical way, I think, right now, and we'll show you that in a little bit. Similar to what we were looking at the time. So you want to go ahead, Brandon?
Yeah, sure. So when we first started this back in October, I think the previous slide talked a little bit about the documents that we're working with, and a lot of documents we're working with have embedded text in them, so we can extract the text out and pretty much read it almost verbatim. But not all of them have embedded text, and then a lot of the embedded text that we get is gibberish. That doesn't make much sense. So what we have to actually do is, like we were just talking about, use object detection to first find where in the document like an invoice date or an invoice number is. And then after that, we can read it using OCR. So to do this, we first started using faster RCNN, and that's the one we're still using now. Back in October, we were also using a framework called Yellow and RetinaNet. Yellow at the time didn't work very well, and RetinaNet at the time gave pretty good results, although right now it's not giving as good results, but we haven't given up on it yet.
And something early on, when we were first looking at these, something that's kind of critical in what we're doing is the way we were going about gathering data. So we got a very big pile of data that was labeled, but it wasn't labeled in a way that we could use deep learning against it. And it's crucial. We knew that at the time. And so we were trying to essentially generate our own results. And that's kind of what you see here is our generation methods at the time had a fairly weak variety, so that the variance within them. So we could generate millions of documents if we needed to, but they looked too similar. So we kept working on additional templates. But since we have adapted to get more power out of the labeled documents to relabel them, really. It's a fairly human effort. We tried to avoid that, but that's really the story of where we're at from October, November to now, is there's just really no substitute for the real stuff. So try as we might to think of all the different ways that we could simulate all the weird stuff that happens in real data. Actually going after our 180,000 invoices, it's just baffling sometimes what you can see in there, but that is a much more representative sample of what we have to do in the wild than all of the generation we were at. And so you can see some results of some teams doing similar projects that have had good results with this. We just did not, and we tried for a long time. So part of the results here, the ones you see on the screen, we've improved a lot. It's some of experimenting with deep learning, but it's also of really unlocking the power of the data that we had found up front.
So just a quick explanation of how fast RSCN kind of works. It's a two-stage approach. So the first thing it does is it finds basically areas in an image. It tries to find like foreground and background. So it tries to find regions of interest, they're called. And then once it finds regions of interest, then you have a box that's a region of interest, and then it can classify that box as being an invoice date or an invoice number or something like that. So there's basically two steps. Then quickly, RetinaNet, instead of doing it in two steps, it basically has one step, and it introduces a new loss function that was introduced in the paper called focal loss, which, as it's training, it finds examples that are harder for it and then focuses on those examples. That way, I guess it's kind of like hard mining difficult examples so that it improves. So these were some of our initial results using RetinaNet. These are trained on probably 7 or 8 different fields, which we've narrowed down a bit recently, and now we're looking for finding main tables in the summary table, which is summary table down at the bottom right there.
Oops. There we go. Yeah. So this is our current way of
So currently what we have is we have real invoices, tons of them, and we are in the process of labeling right now, and just labeling the main table. So once we find a main table, we can use OCR to read that and then parse it. So we can say like, oh, these are the items in the table. This is the price column. This is the quantity column, and then match those things. And then, yeah.
And that's sort of this side. Sorry, we're going a little back and forth. So this is kind of our current anticipated flow. We're working on just about all these pieces now. And so kind of what Brandon's talking about, that main invoice classifier on the bottom with the date, customer, line item table, summary table. So using deep learning to take that, our logo model is actually pretty interesting, and that's something that we'll start integrating. It's a little simpler, but one of the things we really need to find is the document author. And it can be both sides. There's lots of different ways that can exist, but so something we found use for is identifying the logo, and then you can find kind of transition to the OCR that's near it if you can read it. Sometimes the logos are pretty tricky. So we have a logo classifier doing something, and then one other deep learning model that's going to do multi-classes at the same time. So these are independent models on the left part. And then OCR coming in after that. So we've got, coming into the OCR, we know we're going to run the whole document through, and there's a couple ways we can do that. But our classifiers have told us what the bounding boxes are, and so we know how to lock into the OCR results there. And the thing we didn't show, so our first model was going after every single line item and every single column, if you will. So many columns, and it was very difficult to try and get it to find all these things, but what it's much better at doing is finding an entire table and then letting some of our OCR work be able to figure out, given that this is a table, given no information about it, using spacing and things like that to figure out the structure of a table. So if you can bound a table and then send that into some of our algorithms, we've had pretty good success with that so far. And then we do the specific stuff to get our task done, so that the information extraction, which is that even still with the OCR, you've got all these boxes put together. We need to actually format the date, get it in the right way, and send that over to the API. And then matching is something specific we have to do because we have to say whether this is an actual thing. So our task is that we have a recorded data set, and we have to figure out if this receipt is really the right thing that the company said. That's the task we're going with. So we are very short on time. Apologize for that. This is kind of an important one too. So you can see, again, we kind of pulled in the October synthetic data. Very simple table, and you notice on the top, the numbers, 180,000, but it doesn't take necessarily that much, but you can see the improvement of just getting some real data in there. And so those are the 4 kind of classes. These aren't entirely analogous to the October synthetic data, but the same picture was true when we were trying that as well. We've improved vastly over just getting more data in, and now we can target specific pieces of data, so we can kind of run. We don't have a fully operational feedback loop just yet, but we can use those methods when you're close. You can start to use some of those methods, whereas if we're just off on everything, it's almost unpredictable where our mistakes are. So we don't know really how to refine the labeling data set to minimize the amount of human toil to get the data we need. But we really do need it as much as we thought that. Got an extra 4 minutes. So how this connects to driverless, and then we'll see to look at some of the questions. So this is kind of the main point for us. We started with this from the outset. How can we contribute back to the tool? So this is a project that we're working on with a customer, but we're definitely going at it with putting some of these back into the hands of you all. Putting it into driverless so that you can use it as well, and how we can make that generic. Our task is pretty specific, but when you roll it across our documents, although we're focusing a lot on the invoice and the confirmation table, this is really just a start of being able to do generic documents. And so we have specific classes, but we're already starting to see ways to use some of the OCR stuff to do generic jobs that we could apply to anything. So our use of driverless actually is where we're looking at here. Let me skip to that. So we want to add it as a recipe. That would be the ultimate goal for us, is to really put it back in the tool so that you all can pull it down as it is. This is going to it would look very different than anything we've done today. You're actually going to you would have models in place. So our models would then be, you would be able to pull those. So you're actually getting some of the work that we've done, and you can reuse it, much like you can get a COCO model. You can get some of the
Other pre-trained models and stuff. So.
Yeah, exactly. And it will do that task. And we obviously want to make that as generic as possible, but at least opening it up in the work that we're doing so that it's accessible through that way. Stepping back, a simpler, more broad way of doing that would be just to actually put some of what we're doing into the tool so that we can get image recognition models. We don't have that in driverless right now. So that's something where we're sort of paving the way. And what might this take? What would it take to get pre-trained models in? They are very heavy models. How do we deal with that? How do we plug that in? We have some of that in the NLP for sure. So how can we do that on the vision side? Something that we don't really have in driverless right now. Could be a way that we could contribute some of our work back as well. And extended NLP models. So I did skip over that a little bit, but we are using, we have some models in driverless that are able to work with some of the OCR side things. So we found ways to restructure our data set so we can get it to do a simple classification. So the same kind of model that Brandon showed where we had kind of 4 classes, we've gotten some ways where that's shown success as well. So we can get some pretty quick things off to get started, and then sort of that ensemble approach as well. So we can get something really quick to identify keywords, and this is perhaps important. I can't say that we've extended other languages. We've looked at 2 languages so far, but that's going to be a big one for us. PwC is global, and it's going to be important that we can at least be able to have a repeatable story as we move different languages, but that gets into a whole different, the NLP exploration is going to be a big one, but driverless actually has helped a little bit there. If we can get some training data in, a minimal amount, actually driverless was literally perfect right out. Now we were overfit because again, we didn't have quite the variance we needed, so a similar kind of story as some of our deep learning, but driverless was helpful there. But I think what we'll end up doing is exploring a lot of the NLP capabilities we can in driverless and pushing beyond what you can do today. So for example, a simple one would be a character level CNN, which would be useful for some of the things we're doing. We see abbreviations. We see a lot of, if you think of our task in the NLP world, it's similar to, I always think of it as something like Twitter, where you can't use your wide Wikipedia corpus where most of the words are spelled correctly, in full form. You have a lot of abbreviations, things like that occur in our data sets a lot. And so we may see some specific NLP come out to meet our needs. That's one of the big gains of us working on this at PwC. One of the things we bring to the table is a lot of NLP experience, and so we'll see some of that start to get into our models. So these are some of the ways that we hope to feedback what we're doing back into the product, which will be exciting for us to do. And it's nice that we're actually finally getting accuracy that we can feel a little better about on stage.
Questions?
To quickly move to questions, can we follow your work or the work of the other teams that are working on this problem? That's a good question. So we are, so far the logo model is something that we're trying to get into production first. And so it's simple. I'll put it up this slide so you can kind of see where it fits into this. But the very top left, so this is what Shanshan's working on. It's something so we can start demoing what image really is. It's for us to get experience on what some of these models are like. You know, we've done some of this in deep water years ago, but you know, we really don't have that image work in the product. So I think we're going to start to integrate some of these pieces into what we do in driverless, and then perhaps we should do some blog posts. But you know, at least seeing it in demos is probably, that's our typical way of kind of carrying this out. So pushing the bar so we get it into the product in some way so that we can use it. You know, that's one of the ways. We don't, other than doing these talks every 3 months perhaps, we don't have too much other than that. Is there any benchmark comparing Tesseract OCR that was considered? Absolutely for us. I don't have it on stage, but I've been spending this morning and a lot of it. You know, I don't quite have an awesome slide, but the one I'm working on today is, you know, we have a fax. We have a fax coming in of really bad quality, and we have slanted words. You know, the OCR of this is just amazing. And so in these cases, you know, Tesseract, it is fairly abysmal, but it's almost trying to do too much. Like, we only need certain slivers of it. So can we compare to the Tesseract OCR as far as like a reclamation rate is sort of where we're kind of approaching this. So what would Tesseract do? But we don't have any, we don't have anything to share just now, but that's very much what we're looking at, I would say most of January. I was spending a lot of time with Tesseract. So no, we don't quite have a benchmark there, but we'll definitely start to have those in slides like we have here. And the next time we kind of put this information out there. The timeline of bringing the OCR AI into driverless is still unsure. You know, I think this is mature. Our sort of runway looks like this needs to be ready for us to show in front of people with some mistakes here and there, but soon, in about a month or two, kind of start and end. So you know, I would say at least, you know, past that, but for us using it internally. So. How did you create training data for this? How did you draw bounding boxes for? Yeah, this is it was tough. So we've used a couple technologies out there. We looked into vendors, but one trouble we knew we were going to be faced with is that our data set is proprietary. So we tried to work with some that we would be a little more public, and we still have the remnants of that. So we did use a cloud vendor for a little while to do our own work, though. The plan was always to sort of eventually gear towards crowdsourcing. But we really need to use the data set we have. And so we have used internal tools. And in fact, we have open source LabelMe doing most of the work right now. So works pretty well for what we need, produces the JSON. We can convert that to what we want. It's just a really simple Python app, but that seems to do the trick. Supports a couple different modes, but that one I would say so far is working for us. So Label Me is the name of that one that we're using so far. And we have a we have a few people working on this, so many different people doing tranches of a few hundred at a time, and we've gone back and what do we need more of, what kind of thing. So your ambition, general context parser for OCR docs. Ambition, yes, yeah, certainly. So, but right now we're definitely going to be focusing on the business documents that we have. We have a lot of repeatability in ours, but I would say that so far we are certainly laser focused on the tasks we have to make sure we hit our deliverables there. So, yeah, I think launching it would be something probably, again, I'm speaking. It'll be a little while before we can get this in, but launching anything would be probably fairly specific to what we're doing. We've seen some diminishing returns. Again, there's about 6 different document types that we can get with just the main work we're doing, and so hopefully that will work for other things. Invoices are pretty common to a lot of people, so it wouldn't be too surprising if that's probably where it would start, something like that, receipts or invoices. Maybe it's extensible, I don't know. So far, I think we're always pushing the extensibility. We have some kind of configuration-based ways to make some of this easy and retrain, but a lot of this is really early work. So, but I'd say we're pretty focused on the tasks we have, and that's where it would probably show up so far. One of the great use of the OCR is hospital billing applications with handwritten codes. Yeah, I've spoken to some people in medical databases. Will there be a way to map with additional fields? I think you probably could.
It's probably the goal. I think the end goal would be to be able to do that.
Yeah, because that's what we're, the generic ways that we're starting are certainly able to do that. And so if you look really at that flow, as we'll be hammering in on the next month or two, the table parser is handling some of that. So for us, we kind of had to break away from, every single field. So we have a couple fields that are very specific to what we're doing. And then we have the generic table parsers and sending them to the OCR. So the idea of the table parsers is they could be labeled simply, much more simply, I should say. We are still using some of our labeled methods there, but getting that to be repeatable is definitely something where I think we need to get so we can be scalable internally. So that's something we're working on as well. So could it be extended to other data sets? We certainly hope so. But we'll be trying our business docs for a little while. But yes, I've talked to quite a few people who have interest in that kind of thing. So, sorry this went so fast, but we'll continue to keep you updated. This is a lot of our work. We have a big team working on this. So hopefully this definitely won't be the last time we kind of present this work. And hopefully it's exciting to a few of you. We've gotten some questions after the last one, and I think that's kind of why we got up here. Is we've heard some questions earlier today. What are the latest? And that's kind of the absolute latest.
Thank you so much. What a phenomenal Q&A, actually. I think there's a lot of obvious applications for this product in healthcare, finance, insurance, retail. I think we're really excited of what's going to come from this early. This is where R&D, I think there's a lot of R in this part of the development. I think once that's baked, you can then start improving the product once it goes into the field. We think of this as a recipes. Think of driverless AI as a way to then become more verticalized, right, as it starts doing applications. And you can make that your automatic data scientist behind your applications. So a lot of promise, and we hope to come back in the next H2O world with the way you can actually use it and try it and demo it, upload your own invoices, and hopefully submit them for your conference. Thank you. Thanks, Brandon. Thanks, Mark.